Good day, ladies and gentlemen. My name is MorneLabuschagne, and I am representing the Southern African Bitumen Association at today's webinar, where I will be discussing the latest developments in bitumen emulsions in South Africa. Before I start, I would like to give you a brief overview of the topics that I will be discussing during the course of my presentation. The double spray bar system, bond coats, SBS modified bitumen emulsions, reduced solvent content bitumen emulsion prime coats and pre-coating fluids. I'll move on to rheologically modified bitumen emulsions, and then I will mention some of the challenges that we as an industry in South Africa are facing with regards to the above mentioned bitumen emulsions and bitumen emulsion technology. And I will conclude the presentation with some acknowledgements. Okay, the double spray bar system, it comprises of a binder distributor that's equipped with not only a primary but also a secondary spray bar. The primary spray bar applies bitumen emulsions onto the substrate, as would be the case during traditional application methods. This is then followed by the application of a catalyst or a braking agent via a secondary spray bar, either into or onto the tack coat, which then chemically destabilizes the tack coat and results in accelerated curing of the bitumen emulsion. Now, since its introduction to South Africa, this particular system has mainly been used in conjunction with tack coat applications, although it is also suitable for use with bond coat applications prior to the paving of hot mix asphalt layers. On the left hand side of the photograph is a chip seal that was constructed under laboratory conditions by means of the conventional tack coat application process, and on the right hand side the chip seal was constructed by utilizing the double spray bar system. Now, this photograph was taken approximately 20 minutes after the application of the stone chips. The substrates, which are tin lids in this case, onto which the seals were constructed, were turned vertically and placed against the wall, and as you can see on the left hand side, the stone immediately started sagging compared to the photograph on the right hand side where there's absolutely no sagging, which illustrates the rapid setting characteristics of the tack coat when applied by means of the double spray bar system. Moving on to bond coats. Bond coats has been widely used in South Africa for many years. However, some developments took place over the past couple of years, and trackless rapid setting bond coats have become increasingly popular. Now, these are usually manufactured with harder penetration grade bitumens and or the incorporation of chemical additives and or adhesion promoters. If you look at the photograph on the left hand side of the screen, you'll see some pickup of the bond coat by the construction vehicle's tires in the case of a conventional bond coat, compared to the photograph on your right, which was a trackless bond coat shortly after application, and there's absolutely no pickup of the product by the tires of the construction vehicle that moved over it. An interesting paper was presented at CAPSA 2019 where the detail and criteria around selecting the best fit for purpose bond coat, in this case for a particular Cape Town based contract, was discussed. There were some very interesting test methods and selection criteria disclosed in terms of selecting the best fit for purpose bond coat. Some of the advantages of trackless bond coats: the accommodation of construction traffic shortly after application and also at night, very good adhesion to concrete substrates, which is often a concern when it comes to traditional or conventional bond coats. Also good bond strengths, both torque and shear bond strengths can be expected. I'm not going to go into detail because of the time constraints, but this is another slide that was extracted from Boetus's CAPSA presentation, whereby he explained the shear bond strength testing as the torque bond strength testing. Okay, and then also when using trackless rapid setting bond coats, improved compaction of the asphalt layer can be expected because of the rapid setting characteristics of these bond coats. Moving on to SBS modified bitumen emulsions. These are usually rapid setting cationic tack coats for use in chip seal construction, and they are used as alternatives to the traditional SBR modified bitumen emulsions, which have been well known and widely used in South Africa. Okay, this slide illustrates the differences between SBR and SBS modified bitumen emulsions in terms of equipment, manufacturing requirements, as well as manufacturing conditions. In the case of the SBR modified bitumen emulsions, you can see that the bitumen is heated to 140 degrees Celsius, and SBR is introduced into the aqueous phase prior to emulsification. In the case of SBS modified bitumen emulsions, the bitumen is preheated to 180 degrees Celsius and pre-modified with SBS prior to emulsification. You can also see that in the case of the SBS modified emulsion, the exit temperature of the emulsion after the mill is well above the boiling point of water, 120 degrees Celsius in this particular case, which requires heat exchangers to be installed in line in order to create a back pressure that will subsequently increase the boiling point of the water and make this operation possible. Now, I believe that with the correct equipment setup and plant configuration, SBS modified bitumen emulsion production is possible at atmospheric conditions, although this is not currently being practiced in South Africa. Some of the advantages of SBS modified bitumen emulsions: they are faster curing than SBR modified bitumen emulsions. Some degree of polymer separation is usually evident when storing SBR modified bitumen emulsions, but in the case of SBS modified bitumen emulsions, no polymer separation takes place, which results in SBS modified bitumen emulsions being a lot more storage stable than their SBR modified bitumen emulsion counterparts. Improved elastic recovery properties can also be noted when comparing SBS modified bitumen emulsions to SBR modified bitumen emulsion. Okay, here is a stone chip that was dislodged from the substrate in an attempt to illustrate the elastic recovery properties of the SBS modified bitumen emulsion tack out. However, it's very difficult to illustrate that from this photograph, although it is fairly clear that this binder has good elastic properties. Reduced solvent content bitumen emulsion prime coats and pre-coating fluids. Over the past years, bitumen emulsion prime coats and pre-coating fluids have become increasingly popular compared to the traditional cutback based products, and bitumen emulsion suppliers have been striving towards further reducing the solvent content of these bitumen emulsion based prime coats and pre-coating fluids down to the lowest possible levels. Now, the ultimate achievement would be to produce these emulsions which are completely solvent free. Rheologically modified bitumen emulsions. These are mainly cationic rapid setting emulsions with binder contents ranging from 60 to 70%. These emulsions are theotropic, which allows them to be easily applied due to the shear thinning effect when pumped or sprayed. with increased resistance to flow once they've been applied. Now, the advantages include higher application rates as well as application without the risk of runoff against steep. In another interesting paper that was presented at CAPSA 2019, the manufacturer discussed greater detail and also shared some success stories regarding rheologically modified bitumen emulsions applied as tack coats. And in this paper, an interesting fact was mentioned that this particular emulsion was applied at a gradient of 33% successfully without any runoff, compared to traditional or conventional tack coats that's usually not applied at gradients exceeding 8% in cases of 65% binder content emulsions. Now, moving on to the challenges that we are facing as an industry with regards to the emulsions and the emulsion technology that I have just covered in my presentation. Bitumen emulsion suppliers are at varying levels of equipment and product development. For example, some suppliers have introduced technology about 6 years ago, while other manufacturers are unable to offer the same or similar to industry at this stage. Certain developments, although believed to have great potential, is not very popular in South Africa, and there may be a need for the technology to be marketed more aggressively to ensure a bigger buy-in from the local industry. Although proprietary specifications are usually available from the suppliers, no national guideline or specification exists for a lot of the technology and the developments that I have covered in this presentation. In conclusion, I would like to acknowledge the following industry stakeholders for the contribution that they have made in terms of supplying me with the required information which made this presentation possible. Thank you very much.